Hello everyone, today we'll talk about the solution to the problem check if a parentheses string can be valid. By the way, when you try to solve this problem, if you want to find more problems like this, instead of parentheses string, one way that you may call a situation like this is a bracket sequence. It's easier to say, so I'll probably be saying bracket sequence, and maybe you'll find more information by looking also for bracket sequences. But back to the problem. To solve this problem, we should probably use some trick that we know about parentheses sequences. The basic idea is that when we have a parentheses string, a bracket sequence, then in order to check if it's valid, if all the parentheses are in place, we just have to count the level we're at. Whenever we open a parenthesis, we have to go up by 1. Whenever we close, we have to go down by 1. And the rule for it to be valid is that we never go below 0, and also that we end at 0 and start at 0 and end at 0, right? So we start and end at the same level, and we never dip below the starting and ending level. And in problems like this, when you try to just approach it in a simple fashion, where you try to make your decisions greedily, you'll run into a problem in that when you look at a parentheses that you can change, so one that's locked or not locked, by the way, you can think of parentheses as locked, and instead of that, you can just think of them as being question marks, because you really have to decide whether or not to put an opening or a closing parenthesis there. It doesn't matter what was put there previously. So that decision, what to put there, might not be easy to make, because it might depend on what's happening later. So for instance, maybe you could put a closing parenthesis, and in that case the prefix will still be correct, but apparently the only way to solve the test case would be to put an opening parenthesis here, because you'll need to have that high level later when you have multiple closing parentheses that you can change. So this action at a distance to the past makes it a bit difficult to write a greedy algorithm. But there are multiple tricks that we can use. I'm going to show you one such trick, and probably, since this is a bracket sequence problem, the problems for the next few dailies will also be bracket sequences, so maybe I'll get to show you some other ideas. But the main idea, the main thing to remember, is to think about going through the string twice in two directions, and those two directions are essentially correspond to swapping the opening and closing parentheses and their role. And when you think about it in both directions, often you can arrive at a solution just by doing that. Because what we can do here is, of course, it's maybe difficult to tell if a string can be made valid, but there is one thing that we can definitely try to do, and we can try to make it as not invalid, as non-negative as possible. So want to avoid it dipping below 0, the level. So to do that, of course, we want to change everything we can to an opening parenthesis to climb as high as possible. And if we cannot do that, if we cannot, by changing everything we can to opening parentheses, avoid the situation where we dip below 0, then certainly the string cannot be made valid. However, even if we can make a string that never dips below 0 by using only opening parentheses, that doesn't mean that the string can be valid, because it's possible that by doing that, we will not be able to have enough closing parentheses at some point. So there will be some situations where we actually have to use some closing parentheses, and we will not see them by just trying only opening ones. And here is the trick, where you can just run through the string in two directions by swapping the roles of our brackets. And you can try first to go from left to right and only use opening parentheses and see if you can never dip below 0. And then you can go backwards and swap the role of both parentheses. So just look at the string essentially like in a mirror. And then, of course, then you are trying to force closing parentheses and see if again you can have a correct situation. So you will probably end up above where you started and you never dip below 0. Now, the intuition about it, or an interpretation of it, is that at any position where we are, there is indeed some set of levels that we can reach at that position through all the possible choices before that give us a string that will never dip below 0. So maybe we can get some values, we can get maybe value level 4 and level 2 and level 0 maybe. And if we allow also dipping below 0, we can also get -2 and -4. And we can either calculate it just from one direction, this whole set, because whenever we have a situation where we can both have a balance of, let's say, +6 and -4, then we can get also balances between them. Of course, remembering the parity, that it stays the same. And that will be the interpretation. That's the reason that this approach works. But instead of trying to maintain explicitly the top and bottom ranges of that value, we can simply find the top one by going from the left straightforwardly, trying to open parentheses, and then find the bottom one going from the other side. And if they are both to the opposite sides of 0, then we can get 0 by using some of those assignments, and we're happy and we've solved the problem. So, looking at the solution, of course, if we have an odd length of string, then the answer is false. We cannot have a balanced string if we have and not even, so an odd number of brackets. And if not, we have to check both the original direction for trying to avoid closing parentheses, and try the reverse direction, trying to avoid opening parentheses. So a single direction, so this go function, has this zipped and the parentheses we want to avoid. We remember the level, and we are only sad when for a given character, this character is the character we want to avoid, and it's locked. In that case, the level decreases. If it falls below 0, we return false, and here we are guaranteed that the string cannot be created. Otherwise, we of course increase the level, and if at the end the level never fell below 0, we're happy, we return true. So this is indeed the solution that solves it. As I mentioned, the interpretation about maintaining the interval of possible balances is the interpretation here, but this is an implementation of it that you don't have to actually think about this interpretation and still solve the problem by just thinking about solving a simpler problem from the left, from the right, and actually solving the whole problem by like this. It works in this case.